Hello all. I am Preeta Rajiv Shivraman, Department of BCA, sharing with you a small video on the topic of DSA, that is conversion of infix expressions to postfix expressions. Now, coming ahead, let us understand first of all that what do you mean by an infix or a postfix, or what are the different categories of expressions? Now, if you see the slide here, we know that there are three types of expressions what we use for DSA in processing. First is infix, that is a small standard form which we have, you can say the human form of writing an expression, wherein why this is called as infix is the expression of the type A operator B. That is where we have A plus B. For example, if I write 2 plus 3, this expression will be called as an infix expression where the plus operator is between the two numbers 2 and 3. So here, if the operator is between the two operands, we call it as an infix expression. Second is the prefix expression, wherein prefix means something which comes prior. So if we place the operator before the two operands, then we call it as a prefix expression. This is also called as a Polish notation of the expression. Let's say this 2 plus 3, if I write in prefix expression notation, so that plus will come prior and 2 and 3. So by looking at this, it is understood that this plus is obviously taking the two operands 2 and 3 for addition. The third type of category is postfix expression. Postfix means where we are fixing the operator after the two operands. So here AB plus. So this plus is placed after two operands. Hence, this is called as a postfix expressions. Like for the example I've taken, this will come as 2, 3 plus. Now, this is also called as a reverse Polish notation. Reverse Polish notation of the expressions. Okay. Now, before we start with the conversion of going through, let's say, infix to postfix expression, let us understand first the priority of the operators, or we call it as a precedence of operators. Okay. Now, the operators, the highest priority or the highest precedence has the operator, which is called the exponential operator. The second or the next highest is multiply and divide operators. And the last or the least priority is of plus and minus. So if we say by the value, this will be going up, having the least and the highest priority of this operator. This has to be understood. This has to be memorized while we try to convert an infix to postfix expressions. Now, moving ahead, what are the rules or what are the different rules we try to see or we need to follow when I am converting an infix notation expression to a postfix expression notation? And what data structure we are using, that is the most common, that is stack. The first rule is priority of the operators must be followed. What we have seen in the previous slide, that priority of the operators must be followed. The second is no two operators of the same priority can stay together in the stack. That means, for example, if there is a stack which has a plus operator already with it, so you cannot add a minus operator on top of it because both of these operators have the equal priority, right? Similarly, the third rule says lower priority operator cannot be on top of the higher priority operator. Now that means, let's say, take this example. If plus is there, operator is there already in the stack, you cannot push in a multiply operator. Multiply operator, this is allowed. But if suppose, for example, what the rule says is, suppose multiply is there already in there, you cannot push in a plus operator. Why? Because plus has lower priority as compared to a multiply operator. So what needs to be done is this multiply operator needs to be popped out, and then this plus operator needs to be added up. So finally, what will be the structure is this multiply will be popped out and only plus will be there in the stack. Last is any elements in brackets, that is such type of brackets if the expression says, then if we have the opening bracket and the closing bracket, whatever elements are there, that elements must be popped out from the stack. Okay. Now let's see how this is applied, how now the conversion takes place using a stack by taking a simple example. Let's say we have this expression. Convert the given expression from infix to postfix using stack. So this is an expression. Now, how do we start is we scan the expression from left to right. That is, we start from the left side and we scan each character of the expression from left to right. So if we start from the beginning, how do we start is we try to create 3 columns and find out, let's say, step by step, what will be the postfix expression. Okay. So let's say the first symbol scanned is the opening bracket. The stack contains what we have is, now one more thing, any operand which comes in the expression that needs to be pasted into the postfix expression, and anything which the stack has what operators and the opening and the closing bracket. So here the symbol, since the symbol is a bracket, so what goes into the stack, this will go into the stack, and right now the postfix expression is nil. Now, if you see the next symbol which is scanned is, that is capital A. So where does it go is, since it doesn't go into the stack, so the stack contents remains the same and the postfix expression has this A element, right? Next is the operator plus, which is there. So plus, it will go to the stack. So the stack contents will be what? Opening bracket and plus, and the postfix expression remains the same, that is A. The next operator is what? That is the next character which is scanned is B. Now where it will go? It will not come into the stack. It will remain, the stack contents remains the same, and the postfix expression changes to AB because B has been scanned. Now the next symbol scanned is divide. Now if you see here, the stack content is opening bracket plus. Now the incoming operator is divide, which is of higher priority. So this is allowed. So we will push this into the stack. So my stack contents will be opening bracket plus and divide, and the postfix expression remains like this, the same. Next character scanned is C, and what it will does not go to the stack. So it will come to the postfix expression. The stack contents remains the same, and it will be ABC. Right? The next character scanned is multiply. And where it has to go? It has to go to the stack. So which element is there in the top of the stack? Divide. And we know that multiply operator is coming, which has the same priority as that of the divide. So no two operators of the equal priority can there be in the stack. So what we will do is we will pop up what? This divide operator, and we will push in what? The multiply operator. So the stack will now be opening bracket plus and multiply, and we will pop out A, B, C and divide. Now the next character scanned is opening bracket. So this opening bracket is scanned here, and we will try to push it into the stack. So now this is pushed into the stack, and the postfix expression remains ABC divide. Now the next character scanned is what? It is D, where it will go to the postfix expression. The stack contents remain the same, and my expression becomes ABC/D, right? Now the next character scanned is plus. So I'll move to the next slide since there is no space here. So the symbol scanned is what? It is plus. So let us take the symbol that is plus, and my stack contents is what? It is opening bracket plus multiply and opening bracket, right? And here this will come as plus. Now if you see this here, the plus operator is there on top of the higher priority operator, but this is allowed because there is a bracket in there, right? So that has to be remembered. And my postfix expression is ABC/D. So it will be ABC/D here, right? Now the next operator symbol which is scanned is what? It is E. The symbol scanned is what? E. Now I'll put it here where it will go to postfix expression. So the stack contents remain the same, opening bracket plus multiply, opening bracket plus, and it will be ABC/DE. Right? The next symbol which is scanned is closing bracket. Now, when the closing bracket comes, what is said as this closing bracket will go into the stack. Now, when any element is between the opening and the closing bracket, the elements needs to be popped out. So finally, this plus will be popped out and it will come to the postfix expression and we'll be left with this particular stack status, that is only 3 elements. And since the plus operator is popped out, so it will be ABC slash DE and plus. Now, the next symbol scanned is minus. So it will be minus. Where it will go? It will go into the stack. Now, minus is coming into the stack since multiply is already there and it is of higher priority. So this plus is, the multiply it's popped out and the status will be opening bracket and plus. But if you see here, plus and minus, they have the same priority. So they also cannot stay together. So this plus will also be popped out. So finally, we are left with opening bracket and minus in the stack. And since by each operator from the stack is popped out, so it will be ABC slash DE plus multiply and plus. Right? Now, the next character scanned is F. So let us write here, the next character scanned is F. Stack contents remains the same. It will be put in the right-hand side, that is the postfix expression. So ABC slash DE plus multiply plus and F. Now the last operator, the last symbol scanned is closing bracket. So the closing bracket comes here. Now when it has to go into the stack, now since the element is a closing one, so that will be popped out. The element, which element will be popped out? The minus operator will be popped out and the stack contents become nil, or we say it is empty. And finally, we have this ABC slash DE plus multiply plus F and minus. So this is, we have scanned all of the symbols in the expression and finally we get the answer, which is the postfix expression. Therefore, our postfix expression, what we have derived using the stack, the postfix expression of the given infix expression will be ABC slash DE plus multiply plus F minus. This is our answer. So stack becomes very handy when we convert an infix into a postfix. Without a stack also we can do the conversion, but using a stack it becomes, and following the rules of the stack plus the precedence of the operators, it becomes very easy to do the conversion. I hope all of you have understood this small topic taken. Thank you. Have a nice day.